Okay, so for the quiz, what I asked you to do is I asked you to take in two integers and then calculate the sum, the difference in the product, and the quotient. And then I told you for the quotient, I want you to include the fraction. I know that's kind of confusing. I guess I should have said fractional part, or I don't know. Like I don't know what the correct name for the decimal and the numbers that follow is. Is there a correct name for that? Does anybody know? Decimal to so many places. Decimal.
Are you talking about the specific place, or are you talking about everything beyond?
Yeah, like not the specific place. Like I know there's tens, hundreds, thousands, like, but just like that from the point, from the decimal point to any number that follows after that. I always just call it fractional part, but then some people say, well, fractions are like 1/4 or 3/.
It still could be called that, though, because when you do represent fractions with a decimal point with so many stuff on the other side.
Okay, so decimal points, fractional part. I basically I wanted you to read the numbers as integers, but then when you actually do the division, I wanted you to retain the precision of the division. Does that make sense?
Yeah.
So okay, so I'm gonna go and just type this up really quick. I'm gonna hop over to. I use TextPad this time, and let me save this. And wait, Java 1 Canvas, no, shared Java. All right. Demos, chapter 2. I'm going to call this one, I think I started writing this already, right? I could probably just open what I did the last time. Let me see. I'm going to go to File, Open. Okay, so this is where I left off when I was writing this because I wanted you guys to kind of finish this off. So I'm going to prompt the user for his number 1 and his number 2 value. So I'm going to say system out print enter num1, and I'm going to prompt him for num2. I'm going to store those values into the variable num1 is equal to scan.nextInt. And num2 scan.nextInt. Okay, so I have my values. Now I'm ready to perform my math. So the math I want to do is the sum, the difference, the product, and the quotient. So the sum is simple. It's just num1 plus num2. The diff is num1, I guess maybe num2. I don't know. It depends on what you prefer to be your difference. Okay, and then the product is num1 multiplied to num2. All right, and the last one, which is the more complicated one, is this is where I took off points from the quiz for most people, and that is the quotient. Okay, so for now what I'm going to do is I'm just going to say, okay, well, I know I have num1 divided by num2. I'm just going to leave it like that. I know that is not the correct answer, but let's just see what it looks like. And I'm going to print out my results. Okay, I'm going to say sum is, and then print out the sum. And then I'll do diff prod and the quotient. I'm going to save that. And I'm going to, let me put like a new line right here so that it's kind of separated from the input. I'm going to go ahead and compile with Control 1. It did compile, right? In the output window. I'm going to go and run this, enter num1, I'm going to put a 3, enter num2, I'm going to put a 4. It says the sum of 3 and 4 is 7, the difference between 3 and 4 is 1, the product of 3 and 4 is 12, but the quotient is 0, right? So what happened was, even though my quotient is defined to be a floating point value, which retains the decimal places, my actual math was done with integers. So whenever you have an integer and you do math with integers, Java is going to just discard the fractional part. It's just going to get rid of anything after the decimal place. Like even if it's 3.9999999, right? It's just going to just drop off that. It's not going to round for you or anything. It's just going to drop off the decimal places. Okay, so what we have to do is we have to force one of these to be a floating point value. Now I did see that some students tried doing this, where they wrapped it in parentheses, and then they casted the result like that. That's not going to work because you're still doing the division with integers, okay? So if I were to compile and run this, I get the exact same result. I put a 3, I put a 4, I get the exact same thing. Okay, so the correct way of doing this is to force one of these to be a float before you actually divide it. So putting parentheses float in front of num1 forces num1 to be a float, and then you divide that float by num2, and then the entire result will be a float. So when I compile and run this, you'll see that the fraction is retained, and I'm left with 0.75. Okay, so that was the correct way of doing that one. That's what I was looking for that one. The other thing that I saw that students did wrong is like simple mistakes like not putting your name and your info up here, name and info. And the other thing is, if you actually read our coding standard, I do require you to have meaningful names for your class. So I don't want your class to be named something like Quiz 1, okay? Like the name should be indicative of what it actually does, right? So in this case, mathematics, you could have said something like, math with numbers, or you could have done anything, but just if you read through the coding standard that is on Canvas, I specifically tell you not to use like Quiz 1 or Programming Project 1 point whatever. I know some people put like mathematic quiz, and I was like, and I didn't take any points off for that. Okay, but you like where you're gonna have it's Quiz 1 is when you're writing the name and info, you should put that it's Quiz 1 up here. Okay, now the reason why I'm forcing you to do this is because, it's just by convention, like Java classes aren't like named for like its purpose. It's named for what it actually does, right? So the purpose of this was for fulfilling the requirements of Quiz 1, but you want to name the class something meaningful, like what is actually done with inside of that program. Okay, does that make sense? All right, so I took out points for that. Okay, but I mean, for the most part, I think everybody pretty much was able to get, the scanner working correctly, their math working for the most part correctly. So, that was good. I was glad to see that. All right, any questions on this, the quiz? All right. Okay, so with that, I'm going to go ahead and hop into chapter 3. There is a few things to talk about. So here's a breakdown of chapter 3. We're going to talk about creating objects. We're going to talk about the string class. We're going to talk about random and the math class. We're going to talk about formatting output, enumerated types, and the wrapper classes. Okay, this should probably take over 3 class periods. Yeah, so I'll probably do the first 2 topics today. I'll probably do, on Wednesday, I'll do the random class and formatting output. And then enumerated types and wrapper classes will probably finish up next week. I also want to introduce some additional classes. There's the calendar class, the day class, and the simple date format class, which isn't talked about in the book, but I'm going to introduce it to you. So that is something I'm going to require you to know for our midterm. So that's going to be additional. In addition to what's in the textbook, you are going to have to know the calendar, date, and simple date format. Any questions? Okay, so let's go ahead and get started. So a variable holds either a primitive value or a reference to an object. A class name can be used as the type to declare an object reference variable. So here they're declaring an object reference variable string title. So a string is considered to be an object, right? So title is the object reference variable. No object is created with this declaration. An object reference variable holds the address of an object. The object itself must be created separately. Okay, so this is only declaring. So whenever we declare a variable, like I'm gonna hop back over here, like what we did for these integers and where we're gonna store the result, like we're simply telling Java, I'm making this identifier that is going to hold a integer primitive data type. Okay, this one is telling Java, I'm making a identifier called quote is going to be a variable that holds a float primitive data type. When I declare if I were to declare just this part here, I could have just done that. I could have just said semicolon right there, and then I could have just said scan right there, right, is equal to the constructor. But just this statement alone is telling Java, I'm gonna make an object reference variable that is gonna hold a scanner object. So Java knows that, okay, well, scan is now reserved for that object, but I'm not actually doing any initializing of that variable, right? That's not actually done until the very next line where I actually create my scanner object. So this is just the declaration, and this is actually where I'm going to create the object and save it into the variable. Any questions on that? All right, let me hop back to the lecture. The object, okay, so I read that line. Generally, we use the new operator to create an object. Creating an object is called instantiation. That is a definition you're going to need to be familiar with on the exam. An object is an instance of a particular class. So here they're showing you a string constructor. Now, Java has overridden the way the way we create the way we create string objects. You don't need to actually do new string and then pass in a string literal. You can just assign it to a string literal. I think they talk about it in the next couple of slides. Okay, so this is a string constructor, which is a special method that sets up an object. That's another term you got to be familiar with, is constructor. Constructor is a special method that sets up the object when you instantiate it. So it just has a bunch of initialization statements inside of that method that are going to initialize any values that need to be set for your object. Invoking methods. We've seen that once an object has been instantiated, we can use the dot operator to invoke its methods. So here you have a variable called number of chars, and they're setting it equal to title.length. Now, title is a string, so the string does have methods that can be invoked on it. So they're basically grabbing how many characters are inside of that string. A method may return a value which can be used as an assignment or an expression. A method invocation can be thought of asking an object to perform some service. Okay, so here they're asking the string to give back how many characters it has inside of it. And length is a method that you can invoke on a string. Okay, let me just, before I continue, I'm gonna just do like a quick example. So I'm gonna hop over here, I'm gonna go to File, Save As, and I'm gonna make a new folder called Chapter 3. I call this one String Demo. I'll keep all of that. All right, let me get rid of quiz 1. All right, so I'm gonna say public class string demo, open close curly braces, my main method header, public static void main string array arguments. Oops. Okay, so I'm gonna come over here. I'm gonna type name is equal to Mike. Okay, I'm gonna say system.out.println. Okay, now I could use string name is equal to new string and then pass in Mike, but Java has overwritten this to where all I have to do is actually just say string is equal to the string literal that I want it to be equal to. Okay, either one is fine. Obviously, this method, doing it that way, is rarely used because this is so much easier just to write it equal to the string literal. Okay, and I'm gonna just print out the name of this, or the link the number of chars inside of this string. So I'm going to say number of chars in the name is, and then I'll just say name dot length. Go ahead and save that. Compile, run. Okay, and it says the number of chars in Mike is 4. Okay, I could come over here. I can make this bigger. Just type in some random characters, compile, run. As you can see that the number and they're giving me the whole string there, and they're saying is 25. Okay, so this string is what we call an object. An object just isn't data. It also has services that are available to from it. Okay, so there are many methods that you can actually invoke on the string object. If you go to your book, they have a list of methods that you can invoke, but they don't give you all the methods you can invoke. If you want the complete list of methods you can invoke, then you have to go to the Java API. So if we just go to Google and just type Java API, and I'm just going to say 8, and I'll click here, and I'm going to go to my string class. I'm going to just find string, keep searching. All right, there it is right here. Click on that. Okay, and it talks about the string class, and gives you a lot of good information. But if you keep scrolling down, you'll get down to all the methods that you can invoke, right? You can grab the char at and then pass it an index. You can do equals methods. You can copy stuff from here. You get bytes and last index of, there's join, there's replace, 2 lowercase, 2 uppercase, and there's value of, but this is a static method, so it can be called through the class name. We'll talk more about static methods when we get to the math class. There's other useful methods that you can invoke on the strings. Like one of them is trim. I think that's very useful. Basically, just gets rid of any white space that is in front or after the string. So if somebody typed in a bunch of white space in an input, then you can actually trim all of that out. Okay, but the book does have a few methods that it wants you to know, and those are the methods that I'm gonna ask on the midterm. And if you go to, I forget what page it's on, but if you look in chapter 3, there should be a table that has a few methods in there. I know some of them are 2 uppercase, 2 lowercase. There's a substring, there's char at, and we'll talk about all these in a bit. But if I were to call the char at, I could just say char at index 0. And we'll talk more about indexes here in a bit. And I'll just print out what char is actually located at index 0. So I'm going to say char at, I pass in 0. So the index is actually what number slot the char is within the string. Now the very first spot is at index 0 because we start our numbering system with 0, right? So the first spot is at index 0. The second character is at index 1. The third character is at index 2. Okay, so there's that weird offset that kind of throws some students off, but index 0 is the very first char in my name. And you can see that at index 0 we have the capital M. Any questions on that? Yes. I'm sorry.
So when you run it the first time, so I saw Mark and Mike next to it 4. From where you got the 4?
Oh, the 4. Yeah, okay. The very first time I ran this, I actually, right here, I added all these random characters for no reason. But the very first time I ran it, I only had Mike, right? So the 4 came from, I'm actually asking my object, what is the number of characters that I have? So there's only 4 characters in Mike. So it grabbed, it counted them, it said M-I-K-E, and that's equal to 4, so it gave me back a 4 as that value. Okay? Yeah, I'll go through all the methods here in a bit. I'm just going to keep reading through the slides. All right, references. Note that a primitive variable contains the value itself, but an object variable contains the address of the object. An object reference variable can be thought of as a pointer to a location of an object. Rather than dealing with arbitrary addresses, we often depict the reference graphically. So here they're saying if num is 38, then it just, in that variable, right, you defined it to be 32 bits, and you're containing the value 38. But if you have an object reference variable, it's actually pointing to the location of where that object is located in memory, because an object can expand and contract in size depending on what type of data that you have in it. A string is what we call immutable, though. So once we've defined what a string is going to contain, or once we've instantiated it, we can't change its size. It's just going to be whatever we said is going to be within that string. Assignments revisited. Okay, the act of assignment takes a copy of a value and stores it in a variable. So for primitive data types, if you have num1 is 38, num2 is 96, if you said num2 is now equal to num1, then both of these variables are going to have their own copy of the data. That's for primitive data types. Okay, but when we're dealing with object reference variables, okay, here they're saying name1 is pointing to the string object Steve Jobs, name2 is pointing to the string object Steve Wozniak. If name2 is equal to name1, then name1 points to Steve Jobs, and name2 also points to Steve Jobs. Okay, now I can actually give you a better example of this when we get to chapter 4, when we're creating our own objects. But right now, when you assign like name2 to name1, you're basically making what we call an alias. So both variables are pointing to the exact same object in memory. Okay, so there's not two copies of the same object. It's just they're both just pointing to the exact same object. And this can be desired behavior or it can be undesired behavior depending on what you're expecting to happen. So if a string was not immutable, what we call immutable, meaning it can be changed. If I were to change name1 to be like a different name or maybe pull out a character, then name2 was pointing to the exact same object. It's going to see that change as well. Okay, but a string is immutable, so that just means that once it's been instantiated, it cannot be changed. But I'll come back to this example when we get to chapter 4. Aliases. So two or more references that refer to the same object are called aliases of each other. That creates an interesting situation. One object can be accessed using multiple reference variables. Aliases can be useful but should be managed carefully. Changing an object through one reference changes it for all of its aliases because there is really only one object, right? So there's only really one object in memory and both reference variables are pointing to the exact same object. Garbage collection. This is also something that you're going to see on your midterm. When an object no longer has any valid references to it, it can no longer be accessed by the program. The object is useless and therefore is called garbage. Java performs automatic garbage collection periodically, returning the object's memory to the system for future use. In other programming languages, the programmer is responsible for performing the garbage collection. So languages like C++, once you're done with an object and you no longer need it, you actually have to call what they call a destructor to remove that object out of memory. But in Java, there's a process that kicks off that once it sees there is no valid reference to that object in memory, it's going to free up that memory so the computer can use it. In languages like C++, if you don't properly manage your memory, you can actually fill up your computer's memory and your computer will crash because the memory will fill up and it won't be able to do anything else. Okay? But all that overhead is kind of done for us in the Java programming language. All right, that's it for creating objects. I'm going to hop into the string class. Because strings are so common, we do not have to use the new operator to create a string object. So title is equal to a string literal, Java Software Solutions. This is special syntax, only works for strings. Each string literal enclosed with double quotes represents a string object. Once a string object has been created, neither its value nor its length can be changed. Therefore, we say that an object of a string class is immutable. However, several methods of the string class return new string objects that are modified versions of the original. So you can invoke a method called toUpperCase on a string object, and what it's really going to do is just give you back a new string with the original string in all uppercase. It's not going to actually modify that value of that string object. Okay, let me just show you an example of that before I continue. So for instance, just say, well, I have my name here, right? And I just said my name is equal to Mike. And then I'll say system.out.println. I'll just say my name in all caps. And I'll just say name, and I'll invoke the method toUpperCase. All right. And then what I'm going to do is I'm going to just print out my name one more time so that you can see that the original value is still retained. I'm going to say my name is, and then I'll print out a name. Okay, so I'm going to go ahead and compile, run, and you can see that Mike is 4 characters, right? The char at index 0 is M. My name in all caps is Mike in all caps, right? All caps. But then I print out my name one more time, and you can see the actual value that the name variable is pointing to is still Mike with a capital M, lowercase I, lowercase k, lowercase e. Okay, so what was printed out here, it was just a new string just in all caps. It didn't actually modify the original value. All right, so let me hop here, string indexes. So this is kind of like what I was talking about when I printed out the first character of my name. So it is occasionally helpful to refer to a particular character within a string. This can be done by specifying the character's numeric index. The indexes begin with 0 in each string. In the string hello, the character H is at index 0 and the character O is at index 4. See string mutation. Okay, so they give you an example. I'm not going to go through it. That's another example that you can look at. Wait, then they do a quick check. All right, dang it. I'm going to have to explain this with no slides. Dang, but if I write on the board, you can't see what I'm doing. You know what? I think, well, hold on. Let me think through this really quick. Okay, I'm going to put paint. Yeah, there you go. Hopefully this doesn't look too horrible. All right, so can I draw? All right, I can. Let me zoom in. All right, so this is how the indexes work, okay? So I have the string. Man, this is going to be really bad. You know what? I think this is touchscreen. Can I just... Okay. Yeah, I'm sorry. Wait, string and name. I'm so sorry. I didn't really prepare for doing this. Normally I just write on the board. Okay, so that's what I had in my program over here. You can see that's exactly what I had. Okay, so the way the string works, it's actually what we call an array of characters. Okay, so an array is basically a container. So what's happening is I have the string Mike. Okay, and it's in this container that holds chars. Okay, and the very first char is at index 0. The next one is at index 1. The next one's at index 2. The next one's at index 3. Okay, so the way the string's set up, it's what we call an array. We'll talk more about arrays in chapter 8 when we get to the end of the semester. So an array is simply a container. So a string is basically a container of the primitive data type char. So at index 0, I have the capital M. Index 1, I have the lowercase I. 2, the lowercase k. 3, the lowercase e. So if I wanted to reference the k, then I can do char at and then pass it the index 2. If I were to go outside of the range, then you're going to get an error back that says string out of bounds or something like that. We'll run it and we'll see what happens, okay? So this is the way the string actually works. It's simply just a container of chars. Once I've created, I can't change it. If I were to ask for the length on this, it's going to give me a 4. If I were to ask, give me the char at index 3, it's going to give me an E. If I were to say, give me the char at index -4, it's going to give me an error, right? The program's going to crash. If I did the same thing for index 4, right? Index 4 is out of the range of Mike. It's also going to give me an error. Okay, let's go ahead and test this out. Hop over here, and I'm going to ask for the index at index 3. The char at index 3. So I'm going to say char at index 3 is, and then I'm going to say name dot char at. I'm going to pass in the index 3. I'm going to save that, compile, run. As you can see that E is at index 3. Okay. Now what I'm going to do is I'm going to ask for the index at 4. Now 4 is outside of the range of Mike, meaning my name, Mike, is only 4 characters long, right? But since we start at 0, there is no index 4. Index 4 would be right here where there is nothing. Okay? So when I actually compile and run this program, Java's not going to see it as a compilation error, right? But when I run, you can see that once it got to that line of code, the program crashed, and the error was string index out of bounds exception, right? And I asked for index 4, and it's telling me there is no index 4. Like, you're crazy. You know, like, that's it. This is all I can give you. Okay, so you can say that if you want to grab the very last character from a name, then you can simply just always assume that the very last character, let me see, so char at the last index is the char at the name length, right? The length of the string minus 1. Does that make sense? Right? Because I know that Mike is 4, but when I ask for the length of the name, I'm going to have a 4, but my last index is going to be the length minus 1, which would be a 3. Okay, so I'm going to save that. I got to get rid of this line right here because it's going to cause a crash. I'll just comment that out. I'll compile. Going to run, and you can see that it gives me an E. Now, this is actually, you know, robust, meaning I can come over here and I can just change my name to Michael. Right now there's 8 characters. Okay, index 3, this line right here is going to grab the 4th character in my name, which is going to be an H. But the way that I've written this part, it's always going to grab the last character. It's going to take the length of my name minus 1, and it's going to grab the very last index. So when I compile and I run, you can see that 3 is an H, but the L is the very last character in my name, right? Because I simply just went for the length of my name minus 1, right? So like now, if I wanted the last character, I can always assume that it's going to be at that location. All right, any questions on that? Okay, so they give you an example here. If that's, I mean, you should probably go through that. Okay, so quick check. So what output is produced by the following? So they have a string space, the final frontier. They grab the length. I don't know how many characters are in there. I don't know, like 20 something. And then they grab, we need to talk about substring. They don't talk about any of the methods. What the heck? Okay, I'm gonna have to go over those before I finish this. Okay, they grab the substring. The substring is basically a portion of the string. So whenever you're dealing with the substring, the value the numeric value you pass in is where you want to start. And then you can also specify the end index minus 1, but in this case they didn't. So they're going to start at the 7th character and they're going to continue all the way to the end. The 2 uppercase is going to grab the very first, or excuse me, I'm sorry, I'm thinking wrong. The 2 uppercase is going to just make everything all caps, and then the string is going to, the length again is going to be the exact same that it was before, except it's just trying to show you that you did all this work on the string and nothing actually changed. So the output is given to you, right? So the length was 26, the substring from 7, the final frontier, and then in all caps, and then they just grab the index or the length again. Any questions on that? All right, so I need to go over all these methods that are described in the book. So I'm gonna come over here, back to my example. I'm going to make a new file. It's gonna save this as a new file. Go to save as. Instead of string demo, I'm gonna do string method demo. I'm gonna save, and I'm gonna call this one string method demo. I'm going to delete everything in the middle, and I'm going to, this time I'm going to use the scanner class to do some of this. So I'm going to say import java.util.scanner, and here's my scanner that I'm going to use. Oops, my scan is equal to new scanner. Listen to the keyboard. Okay, and I'm going to ask the user for his name. I'm going to say string name. I'm say system.out.println. Say enter your name. I'm not going to do a print line. I'm just going to do a print. That way the prompt is like right next to the input. And then I'm going to save the name off into the variable name by saying my scan.next line. All right, and then once I have the name, then I can just run through all the methods and give you an example of each one. So let me. All right, so I have my book here. Let me just turn to that page that has all the string methods. All right, so on page 105 of the textbook, they show you some methods that they want you to know. I'm going to go through all of those. I'm going to throw in some additional ones that you need to be also familiar with. All right, so the first one is charret. I've already demonstrated that, but I'm going to go ahead and do that again. So I'm going to say system.out.println. I'm going to say something, and then I'll just say name.char at, and I'll just say 0, right, to give me the very first character. Yes.
These are called methods, right?
Yes, methods. All right, and let me see. What should I say? Oh, I'm just going to just type what I'm going to copy, what I'm actually calling, and that's the way I'm going to do this. All right. So that is char at 0, and it's going to print out what's at 0. The next one is compared to. This one's interesting. One, you don't really have to use it, but it is going to be. Am I going to ask this on a test? I think I do have it in the on the exam, at least the final exam, I'm sure. So the name of the method is called compare to. I'm going to read the description of what it says in the book. It says it returns an integer indicating if the string is lexically before a negative value equal to 0 or lexically after a positive value to the string that is being compared to. Okay, so by lexically, does anybody remember what that means? They say lexicographic order, one of those fancy terms that you can impress people with.
In reference to words?
Yes, in reference to Word. So, like what it means is it's comparing the characters in the order in which they occur in the Unicode character set. Okay, so capital values actually come first, then lowercase values. So if you're comparing something in all caps to something in all lowercase values, then you're going to get a negative value because it's lexically before the value it's being compared to, right? If it's all lowercase, then it's going to be a positive value, and that's because it comes after. So when you hear that term thrown around in Java, that just means they're using the Unicode character set to do their comparison. Okay? All right, so I'm going to have to ask for an additional string here. Actually, I'll just, instead of asking for another string, I'll just say string. I'll just say my name. And here I'll put Mike. All right, and so the way I'm going to do this is I'm going to say, okay, well, I'm going to take name, I'm going to compare to, and I'm going to compare to Mike. Actually, I should probably do this like programmatically in case I want to change up my name. All right, and I'm going to invoke the method compare to, and then I'm going to put my name right there. All right, let me compile and run this so you can see what it's doing. All right, so enter your name. I'm going to say Mike. And char 0 is M. That makes sense. And then compare to, and I'm comparing Mike to another string with the exact same string, right? Mike. So they're equal, so I got a 0. Yes.
So is compare to subtracting the values for each of the letters?
Yes, that's exactly what it's doing. And that's how it's coming up with its value. So if I were to enter a lowercase value, let me run this again.
Which one's the
So the one that the method is being invoked on would be the one that you're comparing to the other. Does that make sense? So
like I forgot the math word for it, but which one is being subtracted from which?
so the one that is having the method invoked on, right, is subtracting the one that's coming into the method, right? So if I were to make this, actually, I don't need to make this lowercase. I can just run this and enter a lowercase one. Okay, so Mike is what's stored on that other string that I'm comparing myself to. So I'm going to type in Mike, but with a lowercase m. Okay, so I'm invoking the method on what I'm typing in. So this one is actually after, so the value here is going to be positive. Okay, so the M comes 32 characters after the uppercase M. Does that make sense? So that's why it's a positive value.
Is it the whole string itself that's being subtracted, like the value of every single letter?
I believe so, yeah. I have to look into it, but I believe it actually takes the numeric value for each one. And since all of those are the same, right, all the other places are the same, it's really only giving you the difference between the first letter, right? So, so if I were to type in, like, what letter comes before Mike, or M in the alphabet? L, right? If I would put like, then we're expecting to see a -1. Would you agree with that? Okay. And that's exactly what I got, right? Because that's the difference between the two in the Unicode character set. Yeah. All right. The other methods, like I said, I'm not going to ask you, I'm not going to have you know too much about that method. You're just going to have to know that it returns a positive, negative, or 0, and why it returns a positive, negative, or 0. Okay? Concat, it just basically, it does exactly like adding two strings together. So you can invoke a method called concat on a string. So if I were to say concat and then pass, and then concat, you can see the result is just going to be the two connected together or joined together. So enter your name, I want to put like, and then you can see that the concatenated version of the two strings is like Mike, right? Just join them right together. Another method in the book is the equals, which I think is probably the most useful one. This is the one at least I use the majority of the time for a string object. And this actually returns a Boolean value. Ooh, I misspelled concat right there. This actually returns a Boolean value representing if the two strings are equal to each other or not equal to each other. So the way this works is it's called equals. Okay, it's going to compare whatever string that you're invoking this method on to whatever string that you're passing into the method. So equals, okay, and I'm going to compile, and I'm going to run. Okay, so I'm going to enter Mike in all caps. When I press enter, the result is false because Mike in all caps doesn't equal Mike with the capital M and then lowercase IKE. But if I were to compile and run this again, I can type Mike, and now the result is true because Mike and Mike are equal to each other.
So you can do that for like your password.
Well, for security type things, I would avoid using,
Yeah.
right. But I mean, you can probably do it for just checking to see if that string's already been entered, right? Things like that. But there is a way to ignore the uppercase, and you can also do the same thing with the compare to. There is a method called equals ignore case. Okay, so equals ignore case. If I were to compile and run, now if I were to type in Mike in all caps, you can see for the equals ignore case, I get true, but just for the regular equals, I will get false. There's also a compare to ignore case. I should probably, where was it compared to? Right up here. I'm going to copy that, paste it, and now what I'm going to do is I'm going to say compare to ignore case. Paste it right there, compile, run. I'm going to give the same example. I'm going to enter in Mike, all caps, and you can see that the compare to ignore case returns a 0, where the compare to returned a negative 32. The equals ignore case returned true, while the regular equals returned false. Right? Because they just ignored whether they're capital or not capital. Does that make sense? That's actually the one that I think is probably used the most out of all of these. Linked is another good one. That's the next one. It's giving you, so let me just, linked. I'm going to put the linked up top because we already talked about it. Right up here, I'm going to invoke the method linked. Okay, I'm going to hit Mike. You can see that the length is 4. Okay, I've already done that example. Next one is replace. This is an interesting one. You can actually, remember, you're not actually modifying the actual string. You're just returning a new copy of the string. So if I were to call the method replace, this method actually takes in two chars. So I got to change this up a little bit. Actually, I have to change this up a lot. I think about it. Okay, so I'm going to pass in two chars. Okay, so what this is going to do is going to find a particular character and replace it with another. So let's just say I want to get rid of every I that I have in a string and replace it with a $sign. How about every S? To say you just want to be fancy with how names are written. So every time you see an S, you just replace it with a $sign. So you'll just invoke the method name and then replace, and you'll pass in the char that you want to replace, which is the S, and then the char that you want to replace it with, which is the $sign. So I'm going to compile, I'm going to run. At this time I'm going to put an S in my name, we'll put a Mike's, and then you can see that it just got rid of that S, okay? If I were to run this again, oops, what did I do? Control Z. If I were to run this again and put multiple S's, like just something like that, I'll press enter. You can see that it found every occurrence of S and replaced it with a $sign. Okay. All right. The next one is substring, which is actually one that you're going to use on the quiz I'm about to give you. Okay, so substring is going to give you pretty much a portion of the string that you're trying to grab. I'm gonna go ahead and read the description to you because it's kind of important to know. Because I think it's kind of funny how the one in Java works. Okay, so you pass in two integers to the substring. It returns a new string that is a subset of the string starting at the index of the offset, which is the first integer that you put in, extending to the in index -1. Okay, so we actually have to kind of think about this. So basically, what a substring is going to do is you're going to invoke the method substring. It's all just no camel case, just substring. Going to give it an integer of where you want to start, and let's just say we want to start from index 0. Like we want to start from the very beginning of the name, start from index 0, and then we want to continue until we get to, I don't know, maybe like the third character. Okay, so we put in a 3 because a 3 would be the third character because it stops at index 3 is at index 2, but if you read the description, it's going to end at whatever the end index is -1. So 3 minus 1 is 2. I want to end at the third character. So you have 0, 1, and 2. It's going to include the first characters of the name that is the first 3 characters of the name that is passed in. So I'm going to call substring. I'm going to compile. I'm going to run. Okay, I'm going to enter in Mike. And you can see that it just gave me the first 3 characters. Okay, I did a portion of the substring. I'm going to go ahead and run this one more time. This time I'm going to grab, I'll start at the first character and then I'll go until the third character. Compile, run, I'll enter in Michael, and then you can see that it just grabbed the I and the C. I started off at 1 and ended at the third. So you only had 2 characters there, so just grab the I and the C. Now, what do you think will happen if my name was too short? Just say I had a name that was just 2 characters, like D, right? And then when you got to the point to where you're referencing the third index, which is at index 2, that was outside of the bounds. So you got the string index out of bounds error once again. So you kind of have to be careful about how you, like, where you invoke the substring at, just like you have to be careful of how, like, where you invoke the char at. You know, like, you need to know kind of like the range that you're allowed to operate in. All right, the other methods is the 2 uppercase and 2 lowercase. Those are the last 2 methods that are in the book. Those are pretty straightforward. I already talked about them. So I'm just gonna come up here, I'm gonna put them up top, and I'll just demonstrate them. So you have 2 uppercase, and you have 2 lowercase. Compile, gonna run, I'm gonna enter my name, right? And it just puts them uppercase and lowercase. Pretty simple, pretty straightforward. One of the other methods that I wanted you guys to know is a really useful method called trim. I mean, I use it all the time. The way the trim works is it's basically going to get rid of any white space before and after your name. So I'm gonna call the method trim, and then I'm gonna invoke it right here. And the way I'm gonna test is I'm gonna wrap this with what I call pipe, right? I don't know what other name that has, but if I compile and I run and I simply just type in Mike, you can see that there's my name with inside the trim, right? It didn't do anything to it, okay? Because there really wasn't anything to be done. But if I were to run this one more time and I were to put like some white space in the beginning and then typed in Mike and then some white space over here, press enter, you can see that the trim actually got rid of all that white space. But everywhere else, it didn't, because I didn't, like I'm using the original string, it kept all that white space with the original string. So the trim removes what's in the front and what's at the end of the string. I believe that is it for the methods that you should know, but if you go to the Java API, you can kind of look through this let me just kind of look through this really quick. One of the other ones that I use a lot is a format, string.format, which isn't a method that you invoke on a string object. It is a method you invoke to the string class. I will talk more about that later when we learn about static methods, but that is it. So with that, I'm gonna go ahead and give you a simple quiz, or maybe not too simple, but kind of simple. You're basically gonna have to, so what I want you to do, and this is actually part of the homework from chapter 3, is I want you to write a program that prompts the user for a first and a last name, and then generate a username for the user by taking the first initial from his first name and the last, or the first 5 letters of his last name and combining that together. So for instance, if I were to enter Michael Madrigal, my username would be M and then Madri, right? Because those are the first 5 characters of the last name. So basically, you're just going to take in 2 strings. You're going to call char at 0. You're going to call substring, and you're going to join those all the result together and make a new username for the user. And it's going to be the first initial of the first name and the first 5 characters of the last name combined together or concatenated together. Any questions on that?
First 3 of the first name, first 3 of the last name?
No, the first character of the first name.
Okay.
So just the very first letter of the first name and the first 5 of the last name. Now remember, this won't work if your last name is not at least 5 characters. So it's okay. You can always, not until chapter 11, which we will not actually cover in this class, would you have to worry about handling input exceptions. So you can always just assume that the user is going to enter in a correct name. So I'm going to type up the quiz. I want it turned in to Dropbox by midnight. You feel free to leave if you'd rather do this at home. But if you'd rather not, because you'd rather ask me questions, you can stay here and do it in class. I'm going to look at it tonight, so make sure you turn it in by midnight. So let me just type up the assignment really quick. So I'm going to name it Quiz 3, but that should not be the name of the class that you use for this quiz. Does everybody agree with that? Because the coding standard tells us to do otherwise. So let's see. So let me just add this in really quick. All right, so here is the description of what I want you to do once I finish typing all this out. All right, so I'm going to call this Quiz 2. Dang it, what the heck? Let me edit. All right, so let me come in here and edit the description. Okay, so this is what I'm going to do. Say write a program that prompts the user for a first and last name. Then create a user name for the user by using the first character of the first name combined with the first 5 characters of the last name. Okay? Then I'll put the result to the user. Okay, so here's the example input of how the program should look. So here is an example of the output. Okay, so here's the example. Okay, so you can say something like enter user, or excuse me, enter your first name. Okay, the user's gonna come over here, and he's gonna enter in, to say he enters in Michael Madrigal. Okay, maybe I should make this in all lowercase, kind of throw in that extra. Yeah, you know what? Make the username. Hold on, let me do this real quick. So then create a username for the user by using the first character of the first name combined with the first 5 characters of the last name. And here I'm gonna put in the stipulation all in lowercase. There you go. Yeah, that's gonna make it a little more interesting. Okay, then you're gonna prompt the user enter your last name The user will then enter in his last name, and then you're going to do some type of computation, figuring things out, right, using the methods we just went over, and then you're going to say your username is, and then you'll output, or maybe like, I don't know, let me think about this. What would a computer actually tell you? The username generated for you is, and then, right, that's the very first initial of my first name and the first 5 characters of my last name. So what's in italics is the input, and all this is the output. All right, so let me pre-format that. That looks kind of small, but whatever. All right, let me save that. Does anybody have any questions on this? I mean, it's pretty straightforward. You just take in 2 strings, one for the first name, one for the last name. Once you have that, then you can just plug away on extracting the information that you need. You're probably going to have to make another variable called string username, and then what you're going to do is just take the char at index 0 of the first name, and they're going to do a substring of the last name, which is going to be 0 through 5? Yeah, 0 through 5, because the 5th character in the last name is going to be at index 4. So you're going to put it at 5. And then once you've gotten that, just convert it all to lowercase and then save it back into the username, and then you're good to go. Right? Pretty simple. First step, obviously, is to write, like, just get everything all set up. So if I was writing this program, this is what I would do, right? So this is how I would start off. Let me see. I'll call this one user name generator. That's the name of my program. That makes sense for what we're actually trying to do. Okay, so here's my username generator program. Obviously, you're going to need the scanner class, right? That's pretty obvious, I think. You need a scanner object that listens to the keyboard. Okay, and then you're going to need 2 strings for data. You're going to need one for the first name. I'm going to say first name, and then one for last name. And then you might also want to just make one for username. That's where you're going to do your calculation. Then you're going to prompt for first name. Then you're going to save first name. Right, so you save the first name by saying first name is equal to scan.nextLine, right? Then you're going to prompt for last name, save last name. Okay, then once you have the first and last name, then this is where you can figure out what your username is going to be, right? You can say, okay, now figure out username. And we're just going to say, okay, well, we know that username is going to be equal to, and I'm not going to type it all out for you. I'm going to say the first char of first name combined with first 5 chars of last name. Okay, then once you've gotten that, then you can just say, okay, well, username is now going to be equal to username in all lowercase letters, right? That's the method that we talked about. And then the last thing you do is print username out to user, right? And say your username we generated for you is whatever, right? Pretty straightforward. I mean, being able to prompt and store data, right? Like that, like this, everything that's highlighted right there, that should be something that you're already comfortable with, right? From doing the chapter 2 homework. That's something that you should be familiar with. What's going to be a little sketchy is doing the combining of, like, figuring out how to make that username. It's pretty simple, though. The only methods you're really going to need to use from the string object are char at 0, the substring, and then the 2 lowercase, right? You have to use those 3 methods to generate this username that you're going to make for the user. Any questions on that? Okay, so that's all I have. Make sure you get in by midnight, and I'm going to grade it before the next class, and then I'll go over it on Wednesday before class. That's all I have.